If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, I welcome you all to this new lecture on gate electrical circuits or network solution methods. So here we will be taking again 5 questions. Question number 151 onwards, 151, 152, 153, 154 and then 155. Okay, then let's try to solve these questions. Now in question number 151, a non-ideal voltage source Vs has an internal impedance of Zs if purely resistive load is chosen. Again the same question that we have seen, because the internal having is an impedance Zs. The internal is impedance and the load is a resistance. So it is not a standard case again. So you have to derive. But fortunately we have already derived it. We have seen too many cases are there. 138 we have seen, and here also we are showing this one 148, 138. In every case we have solved this type of where internal is a Zs and your load is an RL. So in this case this RL should be equal to Zs. Again it is not a standard case, we have derived this one. So it will be the magnitude of Zs, directly they have given, that's it. So you can refer from where it is coming. In question number 138 we have derived where your source is an impedance and load is in resistance, then what will be the maximum power. Question number 152, assuming an ideal transformer. You have to be careful about this line, ideal transformer. The Thevenin's equivalent voltage and impedance as seen from the Thevenin's X and Y as terminals X and Y. From here you want to see what will be the voltage and what will be the current. So the voltage is here 1 sin, nothing is given, that is 1 sin omega t. Now because this is open, so your I2 current is 0, this current is 0, secondary side, this side. So if this is 0, your primary current should be also equal to 0, because this is ideal transformer. In ideal transformer there is no magnetization component is 0. There is no magnetization current, it is negligible. In ideal we can assume that it is 0. In fraction of time it is magnetized. So there is no magnetization component. Whatever component current it will come due to I2. If there is no load connected, so it will not replicate any current here, because it is ideal current, ideal transformer. So there is no current here. So because no current here, no drop. So this 1 sin omega t will directly come here and it will be magnified by 1:2 ratio. So you will find 2 sin omega t. So either this or this. Directly you can say your VTH will be 2 sin omega t, because there is no I2, no I1, because it is ideal. So directly this voltage will come here, it will magnify it. And the impedance, what will be the impedance? For impedance you will short it, because it is voltage source, so you will short it. So if you look from this side, this resistance, you have to bring it this side. And while discussing earlier also I told you, if resistance comes here, something by k square it multiplies, but whether it is k square or divided by k square, I don't remember. I have never remembered it in my lifetime. What I have always tried to remember is that if it is going to higher voltage side, then it should be increased. That's it. Because it is going 1:2 higher voltage side, so this 1 ohm should get increased, and this increase always by the ratio square. The ratio is half or 2, that depends on me. If I take ratio half, so if I multiply by half square, then 1 into half square will be reduced 1 by 4. So if I ratio is half, then I have to divide 1 by half square, then it will become 4. If I consider ratio is 2, then I have to multiply 1 into 2 square. Whatever, one is ultimately it should increase. It should be increased from 1. So I have considered the ratio. Someone can consider ratio 2, someone can consider ratio half. If you consider 2, then it is multiply, because it should increase. If someone consider it's half, then he or she should divide it, so it should come 4. For the given circuit, the Thevenin's equivalent is to be determined. The Thevenin's voltage VTH seen from the terminal AB. Again from this terminal you want to see. So if you want to see, again it is a Thevenin's voltage you want to see, not resistance. So no need to connect this that external source we connect to see what is the resistance, because we cannot kill this source. But they are asking only Thevenin's voltage. So for Thevenin's voltage there is no need. You need to find this voltage. That is your Thevenin's voltage. So this is your ground voltage, and this is one node which value you know. This is also one node, and this becomes a super node, because there are two nodes connected in between with a voltage source. So it is a super node. So yesterday in last lecture we have already seen what is the concept of super node. So this is the concept this was there. Let me draw it here so that it doesn't becomes clumsy there. So if I do it here, suppose this is my VA and this is need to be calculated. This is suppose V only. This is 2 volt. This is 1. Everything is 1. This is 20 I. This is 2. And this voltage is we have to find. That is VA. This is my ground. Okay. and this current they have given as I. So if I apply this is my supernode. So for supernode you will write a common equation for the entire node. Whatever current coming out of this supernode is this current and this current. From this node these three currents are coming. So summation of all three should be equal to 0. So what will be this current? What is the voltage across this? V minus 2, because I am considering this side is upper side. So it will be V minus 2 divided by 1 plus V by 1 plus VA by 2 is equal to 0. So this is one equation. And the second equation I told you, you will find a relation between these two. So if you consider V this one, that means you are considering this is plus, this is minus, because this is your reference, this is plus, this is minus. So what is the relation between VA, V and this 20I? You see this battery and this battery, they are connected just one after another. So you can see this plus this will be equal to this. If you are getting confused, then you simply take KVL. There is no harm to take KVL because it is a closed path. This is V, this is 20I, this is 2A. So you move around this, you will find the answer. So minus V, or if you see two batteries are back to back, then this plus this equal to this. Or if you are not able to see, then you take KVL. You can see minus minus, then it is plus. So your VA is equal to V plus 20I. Now what is I? I is this current. This current is V by 1. So V by 1. So VA is equal to 21V. So now if we apply this, because we need VA, so in place of V, so it will be 2V minus 2 plus VA by 2 is equal to 0. So in place of V you put 21 by VA. So finally if you put it and if you calculate, you will find your answer is 3.36 volt. I am not doing it, you can easily do it and then simplify. In question number 154, what they are asking, in the circuit shown below, the value of the capacitance C for maximum power to be transferred to load. Now whether this is a standard case for maximum power? Yes sir, it is a standard case, because voltage is there, resistance is there, these two are fixed. So what will be, what is my standard? This is case 1. What is the standard output? What is the standard conclusion for maximum power? The output should be resistive and this resistance should be equal to 0.5. That was my ultimate conclusion, as simple as it. The output load should be resistive in nature and that resistance should be equal to 0.5. That's simple. So if you calculate this impedance from this one, this should have only resistive part. That means the imaginary part from this should be gone. So if you calculate what is here the idea, what is the Z here, it is what is J XL here? J omega is 100, J omega into L is 5 milli. So if you do it, it is J, so J 0.5 it is. So and J XC, XC is 1 by J omega C, you can see, minus J XC, whatever. So right now we will keep it as XC only, JXC. So let me write it JXC. So JXC will be equal to minus 1 by omega C. So let me put it in this way, then we will see. Or we can write it minus JXC also. This we will say minus JXC, because XC is 1 by J omega C. So this is negative, to indicate this is negative, because if you take it is minus 1 by J omega C. So this one I am considering XC, suppose, so it is minus J, whatever. Ultimately you have to write it, whatever way you do it, you just calculate this one. So what will be Z? This is 0.5 J, this plus these two are in parallel, 1 in parallel with JXC. So if you do it, and if you, I think you can do it. So if you do this parallel combination, this is this. Now if you want to separate it real and imaginary, then you will multiply by conjugate. This is minus I have considered, so one parallel is this into this divided by this plus this, so it will be this. So for removing that, for separating real and imaginary, I have to multiply it by complex number, the conjugate of these two. So from that it will become x1 square plus x square. So if you separate now real and imaginary, you will find the final answer is looking like this: x square by 1 plus x square, and then j part is 0.5 minus xc by 1 plus x square. Then you can think it in two different ways. Either you make it to equal to 0.5 or you make it equal to 0. So both ways the answer should be same, because it should be resistive, then there should be no imaginary part should be 0. And the value of the resistance also, you know, the resistive, because it should be resistive in nature, the value should be equal to 0.5. So if you do either one, you will get answer xc is equal to, suppose if I do this one, xc by 1 plus x square is equal to 0.5, So if you solve, it was x is equal to 1 by omega c I have considered, and 1 by omega square c square is equal to 0.5. Omega is given 100. If you calculate, I am not doing, again you can do it. This is this much farad. That means you can say it is 10 millifarad. So the idea is, for complex number, you multiply with conjugate so that you can separate real and imaginary part. So if you multiply, this one will be 1 square plus x square, this is 1 square x square that is coming. And one part will be minus jx into one part j minus jj will get real part. That real part is separated, x square by 1 plus this much, and the imaginary part has been kept. This is 0.5 and then minus xc by this one. You will have find two parts, one with j, one with without j. Question number 155. The circuit shown below, the maximum power transfer to the resistor R is this one. So again for maximum power transfer, what you will do? So if you see the circuit here, for maximum power transfer, you can see here again you have this node, you have this node, because this is this you will open. Let me calculate the Thevenin's theorem. Let me convert it into Thevenin's. So once I know Thevenin's, then I know source impedance, then I know what should be the value of the resistance, and we can calculate the maximum power. So if you remove this one, then this becomes a node, this becomes an entire thing becomes a super node. You can see. So from this super node, one current is coming this side, one current this side, one current this side, one current this side, and this entire things, including that 3 ohm also, it becomes your super node, because these two will include this node. Both these node will include, and everything in between them should be included. This is not in between them. This R is in between this and this. This voltage source and this R is included in between these two. So that's why everything is included. Now if you calculate this one, if I take this voltage as X suppose, and this voltage is Y, so it is X minus 5 by 5 plus X, oh no, this resistance is not there because you have opened this one, sorry. So only X with only this current, and what are this current? It is Y by 5, and this is also 2 plus 2 because it is also outgoing. So this is equal to 0. So this is one equation, and you write between these two. Now if you see your X and Y, if I consider this means this is plus, this is minus, because this is my ground. Now you see this and this battery are connected just one after another. So this plus C, this should be equal to Y, or you take KVL like the way I mentioned in the earlier question. So X plus 6 is equal to Y. So you can use these two equation, or X minus Y equal to 6, and if you solve it will be X plus Y equal to minus 5. If you solve, you will find X equal to 11 minus 5.5. So this is the required. This is minus 5.5 voltage. Okay. So if this is my minus 5.5, and what is my R? If you're looking around this, if you're looking into this, what is R? If you see from this side, this is shorted, this is shorted, this will be opened. If this is shorted, then there is no need of 3 ohm, so 3 ohm will be gone. So from this side 1.5 from this side, so you will have 2.5 at this two side, so parallel, so 2.5. So ultimately you have a voltage, so this is minus plus, that's why it is 5.5, because this is minus, that's why I am giving. So it is 2.5. So what should be for maximum power? What should be your RL? RL should be also 2.5. So the maximum power P max is equal to B square by, or you can say I square R. So 5.5 divided by what is I? This is 5. This is I square. R is equal to 2.5. So ultimately if you do it, you will find it is 3.025 watt. That's your answer. If you like the video, then press the like button and please give your valuable comments in the comment section.